I'm here to explain one or two things about how to analyze OTDR trace. And if you are not forget, I tell you the meaning of OTDR for those people that are not telecom. So it's optical domain reflectometer. So that is the OTDR. Then I want to tell you how to analyze it using a Connie OTDR. So that's what I want to use today. For example, now this is a trace. I just run this trace and I want to use to explain one of two things. Number one, now you will see that this arrow here now, there's a arrow here. So here now, and you see that that thing come down, it shows that if maybe you use a launch cord, this one will show you that from points 1 to 2 is a launch cord. And if you look at this thing clearly now, and you see this thing, you will see that there's a 5 here. And this thing is showing you a joint, a joint 5. So you know that from joint 1 to 4 are hidden here, under here, which means the distance of it is not what? It's not too much. So that's how you see it like this. But it will start from 1 before it will reach 5 here. So we have 1 to 4 here that is silent here. And most of it, if maybe you use a launch cord, it 1 and 2 will show you that it is a launch cord that you use. But this one now, because of this short distance of the couplers, all those things, using pixels and all that thing, because we run from equipment to equipment, and that's how you see something like this here, which is means 1 to 4. Then this 5 here is showing that there's a what? There's a splice in here, and also there's a splice here. For example, you will see the if you go to under trace info or events here, but I don't want to, I will still go there. It will show you the distance from here to here. Even it is obvious that if you look at this place, you will see where there's a 2 here, so that it is showing you that this one is 2 kilometers. So if you want to use this thing now to just like having the idea, you will see that something like 2 point something, like 2.3 or 2.2 kilometers. This the joint here, and this other joint here, you will see that this 6 joint now will fall on something like 2.5 or 2.6 kilometers before 3 kilometers. So, and that is it. This one, and another thing is that how do you want to know? Sorry, maybe it is splicing or something, or is it splicing the did here in that joint, or they use a coupler. If you look at this trace very well, you will know that in a splicing, the trace will come like this, as they go, it will come down a little bit and keep on moving. So it will, as it move like this, it will come down a little bit and still keep on moving. Like this one, it shows that there's a splice in there. But when it is coupler, maybe they use coupler, it will move up like this. It will move up because there's no hair. For example, this is what coupler will show you, but this one now is not. It's something like this. It will go up like this, then come down and move. You know that this one there's a coupler there, and you know that there's a joint. So that is how to identify maybe the joint is coupler joint or a splice using a fusing splicing machine to splice it. Then once you see something like this, you will know that this one shows that it is end of what? Of the trace. So it is end of the trace, and this is it. So that's why it is advisable that before you will analyze a trace and know what is happened, you must have the idea or know the distance you are running the trace for. So once you so know that the trace is not reach end to end, we call it end to end, you know that there's a cut or break somewhere, and this one will show you that the so meter or kilometer, there's a break there. And if you see this one now, you know that this is 4 kilometers here. You will see where the thing stop here, is stop here. So if you trace it down, you know that it's something like 4.2 kilometers. Without even go to the trace info, you can use this one to know. And this is trace info. Trace info here, once you click on trace info will show you exactly distance. As you can see here, 4.2 kilometers, 4.25 kilometers. So this is it. It will show you the span loss, the loss on it, the total loss. You will see it here. Span length, this is the length. Span loss, this is it. Average loss, the average loss of it. The average splicing loss, which average splicing loss. The maximum splicing loss is this. So those are the things that you will check on it. Then to know more again, you can go to under events, and this under event mostly we use it for troubleshoot. If you want to troubleshoot for high loss, and you have a high loss or degradation, you understand, you have degradation, high loss and other things, and you want to troubleshoot, you now use it to know which joints do we have the high loss, and you will see the loss here. Because of the duration of this thing, that we try to be fast because of the duration. You see the loss here, the reflection here, the attenuation here, the combination of everything here. So this is the number one, how it mark here, 1 2 3 4 5 6. These are the number with the kilometer. So that is for today. Next one, I will explain more about how to analyze OTDR trace. Thank you. God bless you. Bye.